Stream started. Hope. What is happening? I think it started. Hopefully. Okay, here we go. Let's go, guys. Let's go. Where is my OBS? OBS. Okay. I think we are good. Mic is good. Camera is good. Quality is good. Screen capture is good. I think we also should be good. Okay, perfect. Okay, guys. So, what are we doing today? I'm just trying to read some article. It's very late, 12 o'clock. Nothing to do. Feeling bored. So reading some stuff. I was going through George Hart's video, and he was showing this link and asking people to read. I don't know. So, going to read what is special in it. Hopefully, the screen is captured properly. Should I zoom a little bit? Yeah, let me zoom. Okay. What is that? What is this article about? Bitter truth. Rich Shutan. Rich Shutan. Okay. Okay. It's working. La 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 la. Da 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 da. Hope my internet doesn't go away. Copy video URL. La 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 la. Da 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 da. Da 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 da. Okay, don't do that, don't do that. Huh. How the hell I will. Okay, you are unlisted now. Made it. See that. Public. Okay. Now we are public. We are public. We started. Should be visible. How will I check whether I'm live or not? Here. How will I check whether I'm live or not? Okay. Works. Works, guys. Works. Da, 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 da. Let's a link. Copy URL. Copy. Don't give me the thumbnail. Okay. Okay. Okay, guys. Let's close this. Test and test. Right. Okay. Okay, let's read. What is this? Bitter lush sun. Okay, rich. Biggest lesson that can be read from 70 years of AI research is the general method that leverage computers are ultimately the most efficient and by a large margin. Okay, research is generally that a general method that leverages computation ultimately most efficient by a large. Okay, the ultimate reason for this Moore's law, or it rather its generalization of continued exponential falling cost per unit of computation. Okay, most AI research has been conducted as if the time than the typical research project. Massively more computation intelligence become available, seeking an improvement that makes a difference in the shorter term. Researchers seek to leverage their human knowledge of the domain, but the only thing that matters in the long run is the leverage of computation. Looking nice, Raja. Welcome, Mahesh. Now, welcome, Mahesh. So today no chess stream. Today we are doing what do you call some AI reading and stuff. Koda. Bored today. Today no chess. Yeah. Only AI stuff. You want to join? Today we'll read some article and stuff. Not sure whether you would be interested. I didn't check with you. Anyways, see, just when you said computer, there is a chess computer. I mean, about to sleep. Okay, I get it right. It's very late. Enjoy. Some other time you come and give your insights about machines. I don't know, CPU, GPU, all those stuff that they were talking, right? Yeah. Okay, Mahesh. Bye bye. Da, da, da. Okay, what is happening? The only thing that matters in the long run is leverage of computation. Yes, thank you, Mahesh. Good night. Seeking an improvement that makes a difference in the shorter term, researchers seeks to leverage their human knowledge of domain, but the only thing that matters in the long run is leveraging the computation. What's the problem there? These two need not run counter to each other, but in practice they tend to. Time spent on one is time not spent on other. There is physically commitment to invest in one approach or other. The human knowledge approach tends to complicate methods in way that makes less suited to take advantage of general method leveraging computation. What the hell they're trying to say? There were many examples of AI blending learning of this bit lesson, and it is instructive to review some of the prominent to review some of the most prominent. Okay, in chess computer. Okay, finally we're talking. Okay, what they're trying to say in the first paragraph. Okay, I understand. As a researcher, you need result. So to get the result, currently what they're trying is do something so that you get the result. But the problem is we're not taking the computation seriously. Not exactly seriously. It is just what do you say? A constraint maybe. What are we looking for, right? If a smaller model can do the same task, whatever the bigger model is doing, nobody is going to do the bigger model. That's the expectation. But what they want to do is like a generalized AGI. So they want to do a single model to do everything. That's a big problem. In the meantime, let me just do this. And wait a minute, I'll come back. Computer chess and the method that defeated the world champion Kasparov in 1997. Okay. First paragraph the training is okay. I get it. I want to do everything efficiently, but not able to do it. What can I do? In computer chess, the method that defeated the world champion Kasparov in 1997 was based on the deep search. Yes, at the time, that was looked upon with dismay by method computer chess who has pursued the method of leveraging human understanding of this program and the similar structural process with special hardware and software provided vast these human knowledge based on the research were not good losers. Okay, they said that a brute force search may have won this time, but it is not general strategy, and anyway it was not how people played chess. These researchers wanted method based on human input to win, were disappointed when they did not. Okay, I get it. La, 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 la. So, what happened with the chess engine? So, 1997, when the deep mind, a deep blue. Chess engine that beat Kasparov 1997. It's a deep blue. Okay. At that time, this was looked upon. I don't know the Disney in a simple search-based approach with a social and okay. A similar pattern of research progress was seen in the computer only delayed by further 20 years. How the hell it is 20 years? Oh, 2017 is 20 years. Oh my god. Okay. Enormous initial efforts went into avoiding research by taking advantage of the human knowledge. Yes. Of the special features of the game, but all of those efforts proved irrelevant or worse. Once search was applied efficiently at scale, search at scale. Also important was that use of learning by a self-manipulative learn the value function. As it was in many other games and even in the chess, the learning did not play a big role in 1997 program that first beats the world champion. Learning by self-play and the learning in general is like search in that it enables massive competition to be brought to bear. Search and learning are the two most important classes of technique for utilizing massive amount of competition in AI research. Okay. In computational co, as as in computer science researchers initial effort was directed towards utilizing human knowledge so that the less search was needed. Okay, so just to decrease the search space I want to do, and the only much later was greater success in increasing search for learning in speech recognition. Okay. Yeah, okay, so what's the whole idea? They wanted to do the research, search first. But the problem was if you use a search space is going to be high. I don't want to do it in a high, I want to scale it down, so I use a human knowledge. Actually, that's how even the chess was done at the beginning, I believe, if I'm not wrong. So, in speech recognition, okay. In speech recognition, there was a early competition sponsored by DARPA. What the hell is DARPA? Defense Advanced Research Project Agency. What the hell is this? Okay. Including the host of special method that took advantage of human knowledge. Under the okay. Based on the hidden Markov models, again the statistical method one over the human knowledge based on this led to a major change in all of natural language processing. Gradually over decades, where statistics and computation came into domination. The recent rise of deep learning in speech recognition most recently in this direction. Deep learning method rely even less on human knowledge and use even more computation together with learning and the huge training set to produce a dramatic better speech recognition. But it provides ultimate counterproductive and plus a waste of researchers' time. As in the game, researchers tried to make a system that works the way researchers thought their mind worked. They tried to put the knowledge in their system, but it proved ultimately counterproductive. Oh, actually, that is really interesting topic to check. Computer vision there is a similar pattern. Early method conceived of vision searching for edges and generalized cylinders. And in terms of shift feature, today all this is discarded. Modern deep learning neural network use only the notion of convolution and a certain kind of invariance and performs better. That is true. Shift. I'm familiar with the word shift. What is shift features? I forgot. Scale invariant feature transform. Local and base appearance interesting. Yeah, images, another crazy stuff. Okay, this will be plus. As a field, we still have not thoroughly learned it, and we are continuing to make the same kind of mistake. To see this, to efficiently resisting it, we have to understand the appeal of this mistake. We have to learn the bitter lesson that building in how we think does not work in a long term. Yeah. Often incomplete because it is success over favored human-centric approach. What is wrong with the human-centric approach? There is a whole group in Stanford working on human-centric AI. What the hell is the name? Human-centric AI. I don't know, Stanford or somewhere. I'm very sure. Human-centric AI, Stanford maybe. Stanford. This is the one. This is what I was sending. Stanford HIA. Human-centric AI, right? If I'm not wrong. Yeah, human-centered artificial intelligence. The whole department is working on human-centric AI. This one also you have to check actually. They very interesting research they're doing. At least if you see what they're doing, initiative, governance, and referral. Yeah. Again, I heard more news about it, but I don't know how will I find all the papers published by them. I don't know how to do that. But okay, somebody is texting. Riding slow. Wow. Hello, Mr. Riding slow. This is application policy. Yeah, this is what I was looking for. Research program, whatever they have done. So, how do I see the paper given by them? Human-centric AI. HIA develops a new human-centric design method and tools so that AI agent and application design and the creativity to communicate with them. Yeah. So they want to put a human in the loop, obviously. It is actually interesting. So, what do we know? If the environment is fixed, let's say reinforcement learning. I'm trying to learn chess. Should I keep the? What is the last function I should mention? Last function or reward function, whatever the hell that is. If the reward function is designed by human, for the context I am an embedded. I know you from RUS. Oh, that is great. You are from Are you from ECE? Because if you are from ECE, I would know Mr. Riding Slow. I am a embedded developer. Yeah. Thank you, Riding Slow. Do you have any question? Feel free to ask. I will answer. Okay, so today we are looking at human-centric AI from the Stanford. I mean, we reached this place, but the starting point was something else. I was reading an article about what was going on, and we reached here. Now, okay, what is the problem here? What are they saying? Augmented people are more efficient to make this work better, and these breakthroughs will allow great progress in healthcare, education, blah blah blah. Okay, calm down. AI have the potential. La 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 la. Okay, tell me the content. People are social animals. Machines are not. To achieve the board accepted AI system must conform to our. Must conform to the off. When should they speak up? If they require to share resource, how can they balance? I don't know. So what exactly they are trying to do? Come on, tell me the final human impact. Okay, all I know is they are publishing some papers. Human-centric AI. So what? So they are afraid that machine will do things which we don't want? Is that what they are trying to do? I don't know. Okay, we'll go back here. So where were we? We were looking at the shift, but with a modern deep learning approach. Notation. Okay, this is a big lesson. As a field, we still not thoroughly learned it. As we continue to make same kind of mistake, to see this and to efficiently, we have to understand that okay, AI results have often treatable. Oh, this is where we were in. Yeah, agents. This always helps in the short term and personally satisfying to the researchers. But in the long run, it plateaus and the breakthrough even progress in approaching the based on the scaling by competition by search engine. The eventual success is tangled with the bitterness, often incompletely digested because it is success over. Okay, this is where we are. One thing that should be learned from the bitter lesson is the great power of general purpose method, the method that continues to scale with increasing competition even as available competition becomes regular. The two methods that seems to be scale arbitrary in a way are search and learning. Yeah, that's the whole problem. No, you can write the whole machine learning problem into a search problem and also the optimization problem. I think that's the whole AI is actually search, optimization, and finding a better, what is that? I don't know. The second general point to be learned is utilization actual and stuff. Okay, I mean, I don't understand what is special about this one. I get it. Okay. This one is fine. The one which another one I wanted to see was this one. Human-centric AI. What they're doing about do they have the paper? Building a national AI research white paper, Bill of Rights, AI index report. Generative. Okay, I found some nice links. Let's start with this one. Generative AI, the perspective from Stanford HAI. How do you think generative AI will affect your field and society going forward? Okay, don't sell me anything as long as. Okay, some text. Okay, I'm seeing your text. Let me be anonymous for now. Okay, fine. Okay, soon I am looking for vision based processing. Like if you recommend a GitHub repo for face and action recognition C language. Okay, also some place start learning for CUDA and so ROS optimization for ML model like CUDA. I mean, I think it's okay. Let me get this right. So you want a vision based processing. So in that case, you're going to work with image processing, right? So what exactly you want to process? Image process is a very mature field, and if you really want some model, I can suggest. Let me go to here, Hugging Face. Okay, this is your, where you will get all the models you're looking for. Go to Hugging Face. Go to models. You see here, computer vision. These are the models that you're looking for in the computer vision. Face. Okay. Yeah. So let's say if you want to do some video classification, let's say, look at this. You have literally like what, hundreds of models available, 350 models. So let's say if you want to try some model, I don't know. Let me just take most. Let's say. Okay. Almost always you will see something called model card. Okay. This model card will have all the explanation about how to use it, what is the model, and what is the paper. You can look at the paper, and there is a download PDF is there. And if you really want to run the code, you just copy paste this code and boom, you have a result. And if you want to train anything on top of it, everything is given actually. So again, you should know what exactly you're looking for. Okay, so computer vision is like a huge thing, whether you want to do the image classification or video classification or object detection or image segmentation, zero shot classification, anything you try. Okay, even if you don't like this one, I'll give one more thing. Go to spaces. You see the spaces there, you will have a live demo. In that live demo and running apps, all those stuff, I don't know, I'm just going to put image to text, something like that. I think this is one example. Image to text app, I don't want app. Okay, text to image, let's say. So this is like a live demo of it. The code also, most of it is open. Let's say you can type I don't know, monkey running in the space summit. It usually takes some time actually, depends on how people are using, and this should be able to generate. Okay. Okay, I'm waiting for this result to come. Okay, that's where you have to go. But I think almost always all the code will be in the Python. I'm not sure why you want to do it in C, because if you want it in Python, okay, anyways, the particular one is not running, it seems, so currently some issue, but most of the times this spaces works. To provide a service based on this, I only have C language based platforms, so shall I make a microservice? I think it is possible. As far as I know, you can do it with C. There is, I mean nobody is stopping you to do that. But where are you going to run it? That's more important. Since you are saying C, I'm going to assume you want to run it on a very small device, not on the cloud. So if you're going to run it on Raspberry Pi or something, then I'm not sure all this big model will support it. Then you have to look into something called federated learning. Federated learning, yeah, I'm not sure. Yeah. RTOS based processor. What is RTOS? I don't know. RTOS based processor. Multiprocessor time ensuring that process. Okay, what is it? Real-time operating system. This operating system for real-time. Okay. I don't know. I'll just put R2OS and NVIDIA. Let me put on. Can let's see. Can PyTorch run on RTOS? There you go. You got it. PyTorch interface for RTOS C++. So if it can run PyTorch, then it is great, because with PyTorch you can run any models. It's like where I have to do board processing. Okay, I understand. I'm not familiar with how to run it on RTOS, but this is the way actually. Have to check for C++. Yeah, because I see here PyTorch is supporting RTOS, and any model you see here, right? The models I showed needs PyTorch. So usually the current PyTorch, Python, we are connecting using Python PyTorch, but I believe they have it for the RTOS C++. Maybe you can look into that. Yeah. Okay. Interesting. Hope I answered your question. And to start again, the problem is how much compute memory you are having, and all these models I believe is big. So if you want to run on a smaller one, then again you have to find the model. Look at this, you have 350 models. Yeah, this Hugging Face is like a, what do you say, go-to place for any machine learning application, any machine learning model you want, you will get it. And yeah, that's good actually. This Llama 7B is the currently trending one, because it is like ChatGPT. Okay, you can look into that. Yeah, TinyML. TinyML or TinyGrad? I know what is TinyGrad. TinyGrad is running it. TinyGrad I know, because it's like you are going to run the model here. TinyML, let me check what is TinyML. TinyML Foundation. Is it a company really? What they are going to do? TinyML, a microcontroller, DynaMS. Okay, so what benefit they are going to? Why can't I just run a raw C++ and run it? TinyML is a type of machine learning that allows model to run on a smaller and powerful devices. It involves hardware, la, 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 la. Okay, but anyways, you need a compute power to run deep learning. How the hell they are going to do it? They need recommendation. Okay, I'm checking this one only. Okay, neural networks, blah blah blah, foundation, da 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 da, PyTorch. Okay, machine learning is okay. All this story, get it? Then what? Any machine is about la 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 la. Okay, according to dynamics, broadly fast growing field of machine learning. Da, da, da. Okay, see, I get it. You have small memory power, and in a small memory, they are trying to run the model. Tiny amount growth in the recent development of the hardware software engagement since it is requirement of the low energies. Okay, see, if that is again, I mean, I can literally write a 2-layer of neural network and run it. Who is going to stop me? What benefit they are going to give me? The data does not to be transferred to the server for the inference because the model operates on edge devices. Data transfer typically takes time, which causes slight delay removing. Okay, so what, they are going to give me a way to do that? Energy saving, microcontrollers, okay, reduced bandwidth, data privacy. Okay, see, if you want to look at this one, right? Actually, recently I came across this one that Apple is using, Apple using a transformer in their watch, in Apple Watch. I think if it can run in Apple Watch, these models should run. So, what is the idea here? Okay, I saw this news. Okay, the idea is any transformer model you run, you are going to need a GPU, like this really high computer. I mean high compute. But what Apple did is they actually, in their release notes or whatever, right? They told you can run transformer model in the Apple Watch. They said, and everybody was shocked, including me. I was like, how the hell they are going to run it on the watch? So I think along that direction, something like that. Use case being used, application dynamics across. Okay, I want to know one thing. Why can't I just run a simple C++ code that run in on a small machine? I mean, let's say I'm having a smaller model, smaller number of parameters. I can just write a raw C++. Why do I need tiny ML? This looks like agriculture. Okay, I can literally write wherever I want to. Why the hell? Workflow requirement. They're using a TensorFlow Lite. Okay. Many activities this made it. Okay. TensorFlow Lite for microcontroller is one of the most popular framework for the machine learning and the device. It was specifically designed for the task of implementing embedded system, which one is as long as you have very small memory and how to use it, this is the way to go. Yeah, you can just run this one actually. Yeah, there are so many libraries, TensorFlow Lite. I think PyTorch also must have something like that. You can check that one. TinyML. Yeah. Anyways, hope I answered your question, Mr. Riding Slow. Okay, this is a TinyML. What is this? Are they big? How big are they? TinyML. TinyML is a brand growing with the machine application, including the hardware, software, and capable of device. On-device sensor data analytics at extremely low power. Hence embedding. So it's a library or it's a hardware? What are they selling? What? Tell me. Don't make me waste my time. TinyML. Where is about? Oh, this is about. Via TinyML. Okay. TinyML is broadly traced. It is fast growing field in the always senior expert from 90 companies. TinyML capable hardware is becoming good enough for many commercials and companies. Okay, Do I recognize any one of them? I don't think so. Zach Shelby. No. Okay, that's about TinyML. What else we have? PyTorch and RDS. Okay. Okay, the main thing today I wanted to check was QLoRa. What the hell is QLoRa? That's what I wanted to know. The idea was they are going to fine tune the LLMs with some quantization technique. That's what I'm trying to figure it out. QLoRa. La 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 la. Adapter weights. Okay. QLoRa uses bits and bytes for quantization. I want to know what the hell is this bits and bytes also. Yeah, this PEFT also. I mean, all this library I'm using, but I have no idea what the hell it is. Transformers, I know it's coming from Hugging Face. PEFT, what is PEFT? We present QLoRa, an efficient fine-tuning approach that reduces the memory usage enough to fine-tune 65 billion parameter on a single 40-digit using 16-bit fine-tuning. Also, I want to know what the hell is that 4-bit, 8-bit. So idea is they are actually doing this bits quantization. Yeah. Well, the 8-bit 95. Okay, fast implementation of fast implementation of 4-bit convolution neural network for mobile devices. What do they mean? How do they load? Let's run llama 7b. Let's run, guys. Let's run llama 7b in Google Colab. Okay, if it runs in Google Colab, it will run in my machine. Do they have the code? La la la. Okay. Will it work? Clone service array. Why? Give me the answer, dog. Give me the answers. No, I'm not going to sign in. Where is llama? No, I don't want to find it. I just want to run the damn llama. Cane paywall. Don't want to fine tune, guys. I just want to run llama. That's llama in Google Colab. Okay. Do you have any information? Same stupid, yeah. Get the hell out. Okay. System prompt, user, model, and okay, this is fine tuning. I just want to load it and run. I don't want to fine tune anything. Guys. How will I do that? Run llama 2. Same code. Okay, there you go. Okay, how to use GPU on Colab? Access llama 2. Create Hugging Face pipeline. Load. Okay. In 4 different sizes. I understand that there is regular standard fine-tuned for chatting. Okay, give me the standard. Why the hell everything? Give me the damn code. It's the paper, fine-tuned chat model. Ah, what the hell? Web you aren't, but just give me the file. Why is it hard? Let's go, hugging face. Llama. Okay. 7B is good enough. What is 7B? What is this HF? What is HF? This is to enable. Okay, they want me to log in now. The hell? Oh yeah, you have to get llama. I have it in my another machine. I don't think I have it in this machine. You know what? Screw llama. Let's go with Falcon. Let's go, guys. Let's go. Screw llama. Get the hell out of here. Blog went up. I want model Falcon. I don't know. Not 180p. 180p. I don't have a compute power. 7B is good enough. Okay, there you go. We got the code, guys. We got the code. We'll run. Where are we now? CD Raja underscore codes. Oh, we already have a llama. Oh, we already have a llama. I thought I was having it in another machine. Okay, let's go. Today we are going to do it with not llama, but with Falcon. Let's go. Falcon. Okay, CD Falcon, we need an environment, right? Should I put the same thing in llama environment? Otherwise it is going to just take the space only. Create minus name. No, I don't think I need to create. I think the llama one should work. Okay, you can't scroll down, huh? Better to go like this one, yeah. Peter is there. You know what? Let me open VS Code. That is my VS Code. I think I can create here only, yeah. Why to do extra stuff? Yeah, see, we have this code actually. We already have this again. Should we do that? Let's do with Falcon. Where is our Falcon? Where is the code? This is the shit we want to run. Copy this guy. Jupyter Notebook. Can I name it? I cannot give a name, really? Paste. But where is stored? I don't know. It work? Yeah, select. I think Llama we should work. Okay, it is working for now. NVIDIA SMI. Right. Okay, we have space. We have a space. Okay, I don't like this symbol here. How will I save it? Where is my copy? What the hell is this? So sequence, it's a text generation model. Falcon, da 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 da. What's the size? You're asking 7B. I think it will end up in memory error because they're not loading in 4B. Okay, we still haven't loaded the model yet. It's still downloading, huh? Yeah, it's downloading. It's downloading 10 GB. We need some patience, guys. We need some patience. Now we are going to check memory. Falcon. Okay, we are still downloading the models. We'll wait. I have a feeling it's going to end up in a memory error. Because it's a 32-bit full precision model. It won't fit in this memory. I hope so. let it download. Anyone in the chat in the meantime? Nope. is taking more time than expected. Why are you taking so much time? Okay, there is another message from Riding Slow. Check edge impulse. And as I am noob to this AML world, can you explain the flow for any AML based model configuration? Let's say we have a model for facial recognition and my customer wants to add their face. So will that rebuild my whole model considering it's from edge processing? Okay, let's see what's the question. Okay, so what I did, I'm just reading the message from where is it? Let me just, yeah. So what we are reading here is this is what I'm reading actually. The hell. So check edge impulse and assembly. Can you explain the flow of any ML based model configuration? Okay, edge impulse. Let me see what is edge impulse. Where is the browser? Edge impulse. What is edge impulse? Okay, it's a leading development platform for machine learning in the edge device. Okay, build, train, optimize AI for edge. Okay, some stories. What are they trying? Do they have any product? Okay, edge. See, NVIDIA pre-trained model. Okay, they have some stuff. Okay, what was the question? Can you explain the flow for any ML based model configuration? Okay, see, I am not familiar with Edge AI platform, but whatever the thing it is, the underlying idea is they are having some hardware and they want to run ML model on it. They may have some stuff. See, look at this one. This is a Python code, I believe. Looks like a Python code. So they have a library and they are expecting an API key, and you have to give the model and you have to tell which device to run, and it just creates this one and deploy. Okay, they just made like a skeleton of it. Okay, so okay, let's say we have a facial recognition model and my customer want to add their face. So will that rebuild my, no, it will not rebuild the whole model. Okay, okay, I'll give the brief explanation here. Let's say you take a model. Okay, I'm going to take a plain vanilla neural network, single, like it's a 3-layer network, very small. When the model is very fresh, like in the sense vanilla model, it has nothing, so you have to train the model. Any AI model you take, you have to train it. So if your customer wants to add their face, the step one what you can do is you just train your own model. But what's the problem there? You will not have training data, and without training data you cannot do anything machine learning. So to generate the training data itself is a big deal, and especially if you are building an application like facial recognition, only with a few images you cannot do. So that's why we are not going to use your own model. We are going to build on top of a pre-trained model. So what is a pre-trained model? Pre-trained model is the one which is already trained by someone using a huge data. So the model which I showed here, right, in the neural network, in the Hugging Face, whatever I showed, Hugging Face models I showed, these all are pre-trained models. Pre-trained model in the sense somebody have already trained this model for some purpose. Now using this pre-trained model, it is easier for you to build your application on top of it than building it from the scratch. The reason is these model, let's say facial recognition, I think that comes under what, object detection, I believe. Okay, 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 YOLO's tiny. I think that is a good one, I believe. Yeah. So this one, let's say this one just recognizes a person, football, this one. So this is simple model. I'm just giving an example. So this model is trained to identify person, sports ball, and person. So sports ball. So somebody have already trained this model with huge compute power and also the huge training set to do this application. So what we do here is you take this model and run your data on top of it as a additional training data or a fine-tuned data. So the base model will be, let's say this one, YOLO tiny. Then you have your training data and you use it to fine-tune. Now you have fine-tuned data which is customized for your case. So to answer your question, we have, and my customer wants to add their face. So if your customer wants to add their face, you just have to add that one new data and fine tune the model. That should work. So that's how it works in a normal machine learning. But if you want to do it on the edge, there must be some library supporting should be there, and there the key there is which model you are using. Okay, for example, I think tiny sized model, if you come to the model card, where is the size? Do they have the number of parameter? Usually there will be a parameter model. Okay, you can check this paper actually. Number of parameter what will decide the size of your model. So, and I think I answered your question. So for you to add a new one, you don't have to build from the scratch. You take the fine-tuned model, then on top of the fine-tuned model, you use your data and train it some more time, and your model should be good to go. Yeah, and that's the answer for you. So okay, now let's get back to our Falcon. What is happening to Falcon? Why is it down? I guess 7B, right? What the hell is happening? Falcon 7B is 10 GB. Why it is downloading another 5 GB of file? Isn't it? Is it a 15 GB Falcon 5G 7B? I don't know. Falcon 7B versus Llama 7B. I don't believe their answer. Comparison of two. So Falcon is from who? Who gave the Falcon? Falcon is from Facebook, huh? Falcon is from some Abu Dhabi, UAE. Okay. Llama is from Facebook. Text generation. It can generate poems, code, script, musical work. Oh, it can even do the translation. Really? But I don't understand. Isn't it translation is too much of work? Why do they want everything to be done by model answering question? Falcon. Okay, writing is size. Falcon LLMs are very large model. This means they have large amount of multilingual. Open sourcing. Open source means free to use, modify. Yeah. Llama is from the Facebook. I know that actually. What's the data they used? Common crawl. 1.3 tokens in publicly available data. Okay, 1.3 tokens is not that big, right? Like, what if I put, I don't know, 2000 tokens per document? So what's the number we're looking? 7 million document. 7 million is not a big number of document, right? Llama is representing the glow, including the blue benchmark. Features of Llama. Yeah, even this can do language. I don't know why they have to do that. Falcon versus Llama. Falcon has a 7B parameter, whereas Llama B has 40 B parameter. Falcon contains fewer parameters. What? Llama? Okay, I think this is old. This is old. This is 4 months old. The latest one, Llama, also has 7B. Yeah, come on guys, can do better. Can do better. So Llama 2. Okay, where we are looking at bits and bytes. Yes, 8-bit CUDA function for PyTorch. TLDR, I like this. Requirement 3.8 Linux distribution, CUDA greater than 10. CUDA okay, we'll support the list. Okay, CUDA, what is my CUDA? My CUDA is 12.2. Yeah, I'm good. Pip insert bits and bytes. So we just have to pass one parameter. Load in 8-bit equals true. What's it? Max memory is. Oh, 8-bit interface, bits and bytes. What the hell they are doing with 8-bit? Oh, these are the 8-bit. How it saves 75% of memory? 8-bit quantization. Requirement and installation. What is 8-bit optimizer? What the hell is they actually telling? Fast sequence reset. Peft. Yeah, this one also I wanted to check. State of parameter efficient fine tuning. What the hell is parameter efficient? I know how to do the fine tuning and I know this stuff. What is parameter efficient fine tuning? Okay, don't. Okay, everything is going to paper. Is there a way somebody can explain this stuff to me? These finite models. Yeah. What happened? We got error, memory error. Citro. Yes, sir. I told you we are going to get memory error. I told you we are going to get a memory error. Because we have only 12 GB of RAM. And this stupid Falcon is going to take 15 GB of RAM. So, are they using auto model? Auto tokenizer model. Where is the model? Where is the model? Is this model? Is this pipeline? Okay, I think if I give what is looking for load in 4 GB. What is the comment here? Let's see. Load in 4-bit equals true. Now we need to kill this guy. Restart. Yeah, restart. Now run again. Don't download the whole thing again, please. Yeah, loading is red. Now this 4-bit should not take a lot of memory. Oh, still we are running out of memory. Really, guys. load in 4-bit, also having an issue. Should I come in this way? Why are we getting memory error? I'm telling to load in 4-bit only now. What is the issue? This is starting, where it is ending? Should end here now. Yeah, see, that's an error. Fucker has to end here. String indices must be integer. The hell is the hell? I'm literally copy pasting this. Why am I getting an error? I don't like this space. Okay, let's see. Now, hey, the hell? Where is the error? model now. Okay, what do I download? Okay. Load in 4-bit equals true. That's what I have given here as well. Hello Nasif. Um, okay, I want to create a neural network for digital forensic. Okay, I'll come to your question. Let me just run one code here. Give me 1 minute. I'll just come there. I'll just. Should work. I'm trying to run it in 4-bit. This first fellow is giving me error. Let's see. Okay. Oh, it ran. It ran. Load in 4-bit equals to it ran. But why the hell it didn't run here? Okay, we'll see that. Okay, memory efficient. Okay. Hello Nasif. Welcome. I want to create a neural network for digital forensic. Okay, what is digital forensic? What exactly you want to build? Digital forensic. Identity acquiring, reporting. Okay. What should be the data set size minimum? Wait. Okay. Wait. Okay, I'm getting some issues here. Okay. So you want to build neural network for digital forensics. Now tell me what exactly you want to solve. Okay, I understand this, but do you have any particular case? Like I want to detect the handheld weapons. Okay, so anytime when you see that, my first question will be: is there any work have been already done in that domain? For example, I'm going to check handheld weapons. Okay, let's do this one. Deep learning projects. Let's go. Final project. No, we don't want. We want the serious projects. Okay, digital image forensics using deep learning. So there is some work have been done, and this there is no viewer directly or download. No, I don't want to download. Just want to open it. Okay, here you go. Yeah, like guns and knives. Okay, I get that actually. So before jumping to this, right, I want to know, is there anything have been already done? See this one, machine learning in digital forensics. There is one paper. I think there is another one paper. Let's see what they have done already. I think this is the no, I don't want to download. I just want to view it. Can I view it? Cancel. Here two papers. Okay, there is one paper loading. So 2306. So this is very fresh paper, 2023 June. So it's like only 2-3 weeks before. I mean 2-3 months before, I think. So let it load. And digital image forensic using deep learning. Okay, I think this is exactly what you asked for. No, I don't think so. This is something else. So what they have done? Let's see. During the investigation of criminal activities, when the evidence is available, the issue at the hand is determining the. Okay, let me zoom this a bit. Created by video and assurance that the video is real. Today, one way to authenticate the footage is to identify the camera that was used to capture the image or video. While a very common way to do this is by using image metadata. This data can be falsified by changing the video color or even slicing this one. Okay. Given the multi-node solution of the proposed method definition, the aim is to identify such a camera information using the filters followed by the deep neural networks, and this filter solving this problem would have a big impact on the verification of it. Okay, so in this paper what they have done, it's whether the video footage given at the time is correct or not. That's what they're trying to find. So this is from 14th October. Again, very new. This will be a personal project to understand neural network as well as it inclines towards a little bit of cyber security. Yeah, I think that is true. So this paper discuss about it. Let's look at another one paper. This looks like a huge paper, and this is from 8th June. Again, fresh paper in digital forensic, a systematic literature review. Oh, this one is going to give you literally everything. Actually, this is the paper you should read first. This is the paper you should read. So what exactly they are telling? So it's a literature paper. So I believe they are going to cover everything machine learning have done for the domain of forensics. Again, before reading it, we have to check the author and where are they from. This is from Iran, and they have collaboration with University of Guelph, Canada. Okay, so I believe they are a reputed institute. Okay, this is what they are having. Okay, our finding demonstrate the image forensics has obtained the greatest benefit from using machine learning methods compared to other forensic domains. Okay, CNN has been okay. Exactly, I think this is exactly what you asked for. Neural network with some image and gun detection, all those stuff, right? I think from the image to identify this, let me just scroll through on what they're having. Convolutional neural network. Link, please. How will I give the link? Can I copy paste? Will it work? I'm trying to copy paste. Yeah, there you go. That's your link. And it's again very fresh paper, June 9th. So you can be sure that we are up to date. And here, if you see introduction, I think I want a finalized pre-year research. Blah blah blah. Video footage. I mean, they see everything they have cited. You have to look that as well. So research goal, the same to research identification of MLs in the forensics. I think once you read this paper, it will just give you the overview of where and all they have used, and you can pick a particular one and you can do some project there. I think contribution and layouts, visual models of 608. Oh my god, they put so much effort into that. I can see that. Research methodology, primary studies we use. They just filtered. Okay, they're just telling how they found it. All this, see, look at this. They again machine learning, intelligence, and forensic science. That's how they use a search term. Neural network, convolution neural network, deep neural network, deep learning, and digital forensics. These are like basic ML models: SVM, Bayesian, regression, decision tree, k-nearest. There are like the list goes on. And these are the places they collect the data. I really like they put that information as well. And look at this, they have all this preliminary studies, snowball, forward, backward, number of preliminary. So that's how they ended up with 608. Data extraction and analysis. Discussion. Okay, do they have like a summary of anything? Look at this number of publication. So 2010, 11 it was little bit, and 15 it was, then it just exploded. I mean, it just went in an exponential direction. Quite a bit of effort they put. Yeah, exactly. Look at this, so much effort they they put so much effort actually. And if somebody puts so much effort, you can actually trust them. So I would suggest follow all these authors in Twitter and follow their work. You are going to get really interesting uh, information there. That's how I usually do. If I find some paper interesting, find the authors, follow them on Twitter, and just go through whatever they're doing, and it should be good. Geographical region. Okay, look at this. China is having the more publication there. India is having the second most publication, forensic science. Wow, I was not expecting India to have 90. This one, I am not surprised by Chinese, but India is, I mean, I was not expecting. Then obviously US will be there, Italy is there, Korean, UK, Brazil, and the list goes on. Okay, then there is a 298 conference in the journal, number of publication, Springer, elsewhere, IEEE, ACM, databases. Okay, quality, keyword and analysis. Okay, there you go. With image, 347 is about the image detection. I think it comes image detection, something like that. CNN, forensics, deep learning, forgery, SVM classification. Yeah, I think this is like primary studies. Okay. Then, look at this. What are they having? I think my screen is big enough for you. Want me to make it a little bit bigger? Do that. Or I can just make this guy bigger. Look at this one. Image and detection. I mean, since it's a forensics, it's all linked. Co-occurrence. Yeah, it's fine. Yeah, and it's mostly about image. Then something with audio is there. Tree based. Yeah, most of it is going to be convolutional network and deep learning. Expected. CG and fake detection. Okay, that is like a huge one. Do they have a list? There you go. Table of content. There you go. Then our multimedia. Okay, this looks a little fine. Let me just zoom it out. A bit push this also. Camera and phone identification. Again with image. And audio, video, primary source identifier, authorship, attack and malware effect. What is this? Cyber attack. Wow, cyber attack also comes under this domain. Okay, didn't know that. Attack and malware detection. Oh, look at this fast Fourier transform. That's a good thing about literature survey. You get to know about everything happened before and also now. So fast Fourier transform at the time, before this deep learning, everything is very crazy. People are working on it for very long time. FFT, especially with the CCC. Yeah. FFT is fast Fourier transform. Yeah, FFT. Yeah, FFT. Fast Fourier transform. So usually how it works is, before this deep learning comes, let's say if you have a data, right? Any signal data, anything, whether it's let's take audio signal, right? So you cannot run a direct neural network on top of it. You have to extract the feature from it. So to extract the feature in the audio domain, there is a spectrum, there is this, that, and one of the main and useful feature is fast Fourier transform features. Yeah, and that is a huge, before this comes, right? FFT was very famous. Yeah, feature extraction technique, you can put that way. Data discovery and recovery. Okay, discovery and recovery. Yeah, In data theft, regression tree performs better than neural network. Yeah, yeah. Then we can use DSPs for that. Digital signal processing, right? Yeah. I mean, if you are from oh, writing slow is here. Okay. So DSP is a digital signal processing, and FFT is a part of it. Yeah. Moreover, in the data wiping, these files are deleted. One of them will eliminate random forest with high accuracy can. Yeah, see, there is a actually, see, I wanted to tell you here. Look at this one. Regression tree performs better than neural network. Again, any machine learning problem you take, there is no such thing as one algorithm solves everything. That's like very common for any problems actually in machine learning. It's always based on your use case, what kind of data you are having, how good your data is. That's all it's going to decide. So for this particular case, regression tree outperformed neural network. So you don't really need a neural network sometimes. Okay, so just keep that in mind. So before throwing neural network, you have to make sure none of the other things not working. At least the amount of accuracy you're expecting. Yeah, future research direction in ML and DF. Yeah. So yeah, ontology. If you can find ontology, that is really great actually. Like every domain you go, there is going to be ontology. Oh, what is this? Mind map of primary studies. Can I zoom it? How will I zoom it? No, it's not there. Sorry. Then conclusion. What? We are only 31st. Oh, okay. The paper is 31 page, but these reference papers is taking more page because I think they said some 600 papers, right? Look at this. I think they just literally cited all the paper. That's what it is. It's, yeah. Okay. So the literature survey is so huge, but the actual paper is only 31. I think this is readable. Like it's like a proper 2 hours you spend. Go through whichever particular domain you want, and it should be fine. In sketch facing, yeah. Nice way to escape plagiarism. No, no. Actually, plagiarism will figure it out. For example, the citation paper, right? This one will actually be there. If you put this one, somebody else must have cited the exact same thing for some other purpose. So that will match. So usually reference will not be a part of your plagiarism. I don't know what is it, software, something like that. Yeah, I have experience. That's why I'm saying reference usually. Yeah, yeah, it can come. Anyways, that's the discussion here. They have quantitative data, qualitative data, future direction. Check the future direction and yeah, we use the double quotes. Writing skill also have experience. Since you are from Rama, yeah, I guarantee you know that tricks. Yeah, that is true, Mr. Riding Slow. Yeah, yes, Nazif. I think once you go through this, I think you'll get a good idea. Yeah, that's true. Classic, yeah. I remember once we used, someone used the whole document into the codes, and it was telling like, what is it? Only the title was went to the right, and it's like zero plagiarism. Everybody is shocked. I remember that. Yeah, yeah, sure, Nazif. Feel free to ask if you need anything, and make sure to follow these authors. Find most of them will be in the Twitter. See, you can go to Google Scholar and try to follow them also. Where is it? Usually they will have it. Okay. And usually the last author is going to be the what is the name, mentor, something like that. I think, see, this is the person you are looking for. Canadian research chair in cyber security and threat. Okay, this person you have to follow if you are going to this domain. Look at it. I found him on his Twitter. Go follow him. Yes. This login they are going to ask. Okay, not now. Where is it? Copy link address. I'm going to open it here. Wait a minute. There you go. This is the person you're looking for. Follow him, and if you see his post, you can know what and all he is doing. Deepfakes, fuel, I don't know, misinformation, deepfake detection he is using. Yeah. How will we know? How will we see his post? This is retweets and likes. Yeah. And also they will have like usually a Discord channel or something. You can, I don't know, not all the research group, but most of the research group will have it. Okay, so and looks like he's not so active on Twitter, but you can follow him. Yeah, there you go. And whenever you find any paper interesting, always try to see their research group. Yeah, I think that's fine. Anyways, okay, that's it about digital forensics, machine learning in digital forensics. Yeah, okay, I'm going to close it and you can read more. Yeah. Would like to take notes for this question. Yeah, definitely. You just come up with a question. I mean, if I know that, I will answer you. As I saw CUDA dependency there, and these days in perspective of embedding also, CUDA is getting a good attention for ML optimization for hardware. I would like to know where can I start learning CUDA, like its utilization, its parallel processing for prediction and recognition, or like any JTBR. Where can I get my hands dirty? Okay. I already have a system with 24 GB RAM. Okay, that's really good machine. And NVIDIA graphics. Okay, so I expect system properties is not an issue. Once I start switching to Zetson Nano. Okay. What is Zetson Nano? I don't know. For lane tracking like this could also, if you can give some inputs for this JD, I mean. The big block I should be learning for this. Okay, riding slow. Okay. Proven experience in designing, deploying, managing deep learning models and workloads. Strong knowledge of parallel computing architecture, distributed computing and optimization technique. Okay, experience with HPC framework. About what is HPC framework? HPC framework. What is that? Okay, sorry, HPC framework. Okay, I don't know what is HPC framework. High performance computing. Okay. Such as TensorRT, CUDA, OpenCL. Okay. Okay, Mr. Writing Slow, I will answer your questions. Okay. First. Okay, as I saw CUDA dependency there, these days in perspective of embedded, CUDA is getting more attention for ML optimization for hardware. I will answer why this is happening. Okay, so I wish I have a board to write. I would write nicely and tell you. Okay, I'll try my best. Okay, so how will I explain? Okay. Okay, I will just answer now. Then maybe we'll continue if you have question. What's the problem? Okay, we are coming from the base machine learning models. Okay, take any machine learning models, deep learning models in particular. Every deep learning models, all it is happening is matrix multiplication. If you want to put it in a simpler way. Okay, there is an input, some data is coming. There is a neural network and there is output. I will give some input, I'm expecting some output, you have to optimize in between. So the whole neural network is you can think of it as a matrix multiplication. That's exactly what's happening inside the neural network. Okay. Now the thing is matrix multiplication, if you can parallelize, since we are going to send a bunch of batches, one value is not dependent on the other batch. Let's say I'm giving 5 batches, like first data one matrix, second data one matrix, third data one matrix. They are not related. So just to give overview, you can think of that as a matrix multiplication. And think about simple matrix multiplication. Okay, matrix multiplication. Okay, simple matrix multiplication. So look at this one. When I have to multiply these two matrix, we know this is how we do that. But if we are doing it, let's say in a CPU, like I write a double for loop and write. If I have to write a for loop, what will I do? This one multiply with this one, this one. So I have to do row 1, this is so. But the problem is, I can do everything at the same time. My matrix multiplication is not, for example, the first number is not depends on third number. There is no relation. It's like not like only when I get the first number I will get the third number. So if you can parallel process this one, it should be fine. And this is going to happen in a huge scale, like a big number and big models. Okay, so in that situation, just for parallel processing, a GPU is required. Now again, why CUDA is winning? These parallel processing is happening with NVIDIA. CUDA is the direct framework which does it. Okay, there are other platforms which are coming, but for now CUDA is the one which is doing it, like CDN, and if you really want to put that in a way. Okay, so this PyTorch and TensorFlow is an interface which talks to your CUDA code. CUDA I think underline C++ or C, one of that. The Python, PyTorch or TensorFlow framework talks between your Python code to the NVIDIA. That's why we are depending on GPU. Since we are depending on the GPU for any ML model, just for it to make it fast. I think this is lengthier, but just to answer your question, ML model is a matrix multiplication. To do matrix multiplication, you need parallel processing, make it faster. That happens with the NVIDIA and CUDA. CUDA is supporting PyTorch and TensorFlow for a very long time. Obviously, they are trying to do it with AMD, with Apple, everything they are trying. But current winner is NVIDIA. That's why everybody is moving towards CUDA. Can you do it without CUDA? You can do that. And I think then for that you have to test, I think this one. Where is it? Yeah, look at this one. PyTorch. Okay. This is like, I think I just went to all the direction, but just to give this one, if you have CUDA, there is a way. Then there is ROC, and if you have CPU is there. And if you are in a Mac, again for Mac also they are supporting. So from PyTorch side, they are supporting all sort of it. Okay, but the problem is it's not stable yet. So only the go-to option is CUDA. That's why we are depending on CUDA for every machine learning problem. Now that is clear why we need CUDA, because CUDA can make your process faster. You can run it without CUDA also, but it will be slower. Only for that we are using. Okay, that is your first question. CUDA is getting a good attention for ML optimization for hardware. Exactly, only for a speed purpose you need a CUDA. And second question you asked is, and the second question, I would like to know where can I start learning CUDA, like its utilization, its parallel processing for prediction or recognition, or like any jitter probe where I can get my hands dirty. Okay, if your goal is to run a ML model on GPU, right? If you want to run it on GPU, all you have to do is take this PyTorch code. Again, I'm going to tell it in Python, then you can switch it. Okay. Yep. If you're using Python, PyTorch, if you're using, look at this one, you even have a C++ here. This is what I think you're looking for. You just need this particular library. This one you put, and I think this one should be, I think, straightforward for you. I'm familiar with only Python, so I don't know about C++, Java, how it works. But in Python, all you need is single line change. CUDA, you just have to you just have to add one more line. Use GPU. You know, if you see a GPU, use GPU. You just give one line, and the whole code will run in the GPU. I think some will be there for C++ also. If you are using this library, you don't have to go into how the CUDA works, what is CNN library. You don't have to go that detail, at least to start with. A straightforward PyTorch should be able to run it. So you just need to run the PyTorch code. So for your second question, you don't have to learn about CUDA. You just have to learn how to run it on CUDA, at least to start with. Then you can go deeper and see what is happening in the backside. Okay. So that is answer for your second question. GitHub repo, I would still suggest stick to the official site PyTorch, and whatever the tutorials they are having, it should be at least, you know, to start with, it should be good enough. And yeah, here you go, C++, and CUDA extension. Look at this one. I think this is what you're looking for. How this C++ and PyTorch is talking. I think this tutorial is going to be very helpful for you. Autograd in C++ front. Okay, I have never worked with this, but I think you got the idea here, right? I think if you really want to try experiment, right, go here, C++ code, just to understand whether it is actually using the CUDA. Look at this, they have the nice input output, full code tutorial is there, literally. Custom autograde function. So if you just go through this, you will get an idea. Maybe once you go through that, and if you have idea, maybe we can compare how this is a different Python code. And yeah, and the translating, look at this one. Look at this one. I just said I only know Python. Now they are literally giving me, if you know Python, how to convert this into C++. It's so chill, so nice. So yeah, and always stick to official site. Don't go into some random article. They will tell this, that, and instead of jumping around, it is better to stick with the official PyTorch and do it. Okay, that's your second one. And the third question is, I already have a system with 24 GB RAM and NVIDIA graphics card. Really good. So I expect system properties is not an issue. Okay, once I understand, I will switch to Zen Nano for lane. What is Zen Nano? Zen Nano. What is it? Okay, this is another NVIDIA. Okay, I don't know this. Okay. Yeah. It is compatible with open source. Okay, so this is like a specialized hardware just for that. Okay, makes sense. Okay, so if it is from NVIDIA, I'm very sure it should support CUDA. If it supports CUDA, you can run PyTorch. So if the PyTorch can run, it can be either Python or C++, whichever you like. I think it is cool. Okay, and what was this CUDA? Yeah. Okay. 24 GB RAM, so I expect system is not an issue. Yeah, you have 64 GB RAM, and to start with, don't take bigger models. Okay, for example, this Llama Falcon, whatever I do, it's a bigger model. You can take very smaller model, which takes my machine is here to 12 GB RAM. I try to use as small as possible. Even there is a 500 MB model is there. Just to do experiment, if you want, you can start with a smaller model. Okay. So just because you have 24 machine, not necessarily bigger model, even the smaller model, if it can works, it should be completely fine. Yeah. Okay, where were we then? Okay, also if you can give some input for this JD, I mean the big block, I should be learning for the following. Okay. Proven experience in designing, deploying and managing machine learning model and workloads. Okay. If you can do, okay, just to answer the question straightforward, here you have the model. Okay, this is the bits and bytes looking. Where is this? Okay, I'll just open them. Yeah, Hugging Face. Again, this is where we go. Object direction, let's take the smallest model, whatever is possible. I don't know, some YOLO tiny or some model. Okay, this is the model. This is your code. Okay, data set benchmark, again. Okay, this one they are just giving everything. Look at this, how to train your model. Now if you want to, for this JD, right, design, deploy, manage deep learning model and workloads, go here. Where is this tutorial? Docs. Okay, not the docs. Where is the tutorial? Really? I mean, I know, I'm very sure they have the tutorials. Let's see. Hugging face, model space, docs. Really? Okay, it is going some other direction. Okay, I'm very sure they have the documentation. Train. Okay, you can use auto train. Fifth inference optimization. Okay, you know what? Let's go run somewhere. There you go. Here we have. So this is natural language process, but you don't want natural, you want computer vision. Let's say image classification. Go here. There you go. Just read it, run it. Again, this is in Python. I don't know how it works for C++. It should be there. All these codes are available. You just have to take it, run it, reprocess. There you go. Don't do PyTorch. Never touch TensorFlow. Okay. If you are doing everything in PyTorch, stick to PyTorch. Otherwise, you'll get so crazy. Okay. So don't do TensorFlow. Stick with PyTorch, I would suggest. There you go. I think once you are able to train, if you just pass it, you will have a full idea what is happening, and their documentation is pakka perfect. Yeah. Okay. That is answer for you. Then the next one is storage knowledge of parallel computing architecture, distributed computation optimization technique. Okay, see, distributed learning, I don't know whether they are mentioning distributed optimization of computing. Yeah, so distributed computing is another one domain. So instead of running in one, you can run it in multiple. There is a whole section of it. I'm not getting it. I know I have seen there is not this one, I believe. Not federated learning, I think. Yeah, I think this is the one. I mean, distributed but decentralized is different, right? This is different actually. So this is like a main model will be in the middle, and I think this is not the one. Distributed computing is different. I don't have much experience with the distributed learn cases because I never had like a multiple GPU to try. But this is again, if you know how to run it on a single machine, there is a Python. PyTorch itself will give you how to run it on multiple GPU. PyTorch in what is a distributed system. So just to get the look at this one. I think this is what I'm looking for. Distributed overview. Here they have given whatever. I think this is what you're looking for. Data parallel training. This. I think if you just go through it and read it, you will get an idea. I don't have much experience with this one, distributed systems, but I'm very sure PyTorch, if you know how to run it without the distribution, it is easy to run it. Okay, so I think this should be fine. And coming to your last question, experience with HPC framework libraries like Tensor, RD, CUDA. Again, see these things. If you know how to use PyTorch, and PyTorch will connect with everything. You just have to read it a bit about CUDA. I think that is fine. I think for you, I would suggest learn PyTorch with the C++ and go through their documentation. Spend some good amount of time. How they are talking to CUDA, then what is CUDA is doing. I think if you can do that, it's you are chill actually. this OpenCL, OpenMP, CUDA. I think these are like OpenCL is the AMD's one, right? If I'm not wrong. OpenCL is used to for, yeah, I think I know this is like a similar to CUDA, but something else, right? It can be available in the portable basis. Yeah, because I know this OpenCL library will get downloaded whenever I try to do that. Platforms and it was, yeah. Then what is OpenMP? I don't even know. Wait, what OpenMP? Again shared memory. I don't know. I'm very sure. I believe PyTorch should have that. I still believe in PyTorch. Okay, there you go. Performance tuning. OpenMP is utilized. There you go. Where is our OpenMP? There you go. Stick to PyTorch. That's what you need at the end. So PyTorch should have, look at this, they are having how to use this one. So, and anyways, I don't have much experience, but if you have a machine and if you have stuff, and this one should be exactly. PyTorch is mostly everything. PyTorch is the guy who can talk to all kind of GPUs which you are having. So if you just learn PyTorch and how to talk PyTorch with this, I think you will be confident enough to face that interview or this one whatever you asked for. The same thing even TensorFlow can do. Okay, whatever PyTorch is doing, TensorFlow also do. But I would suggest don't mix between these two because you will get confused. Like I was using TensorFlow for a few years. Then I switched to PyTorch. Once I switched to PyTorch, I never went back to TensorFlow. And TensorFlow became 2.0, 2. And it is going in different direction. So PyTorch is right now compared to PyTorch is good for, preferable for me. And most of the research community likes PyTorch, and the PyTorch code is easy to get. So stick to PyTorch. And no, I really want TensorFlow means then there is something TensorFlow also is there. The TensorFlow also will have what is it, OpenMP, right? They also will have definitely. Yeah. No, they don't have it. Okay, at least PyTorch gave it in the first line, but this one is not having it, TensorFlow. Yeah. Okay, that's your answer for your question. Hope I answered, answered your question. Yeah, riding slow. All the best wishes. Yeah, since you have 24 GB machine, I mean, you can run literally any model you like. Especially, you know what I'm looking for is bits and bytes. I don't know whether you saw that or not. So what exactly that is trying to do is, if you have a bigger model, we can still load it in a smaller model in a smaller way, and you can run it. That's what it is, bits and byte. So even the code which I was running, this model was bigger size, and I was not able to put into my memory 12 GB RAM memory. I couldn't put. That's why I loaded with this single line. This is again coming from Hugging Face Transformer. Load in 4-bit, and the memory is like 1/3 of it. So now whatever I want, I can do with this model. So this is one way you can check. Again, yeah. Yes, took notes. Okay, thank you. Hope really happy I was thankful. Yeah, the model will become small in size then. Okay, see, model sizes depends on number of parameters. Okay, so think about this one. You have a model which has 10 layers, and each layer is having 10 let's say neurons, and each neuron needs 10. So 10 10 10, it becomes 1000, right? So 1000 numbers you have to say. So this 1000, what they will call as number of parameters. So if you look at here, there is a Falcon 7B, right? It means it has 7 billions parameter. And any model you see in Hugging Face, it is going to be in the billions or millions. It won't be in the small. So let's take our case, okay? We have 1000 parameters, and 1000 parameters 1 KB. 1 kb model, and no, not the okay, 1 kilo, I mean, okay, let's keep it 1000 parameters. Each one is a float pointer, so each float pointer needs some number of bits. So based on that you will calculate the, let's say each one is the let's say 32 bit. Okay, then to save this 1000 number you need 32,000 of it. So 32 kb will be the size of the model. So similarly, if you see 7b and each one needs 32, how it is, yeah, 32, yeah, yeah, exactly. So number is like that. Okay, I'm not exactly sure about how to save, and also when they save the model they will not directly put it something they will do, they'll just shrink and keep it. But idea is same, number of parameters will decide your shape. That's what uh, that's what it matters. And here if you look at this one, this model is 7 billion parameter, and to save each float point variable you need some number of what do you say, bits, 32 bits I believe, and that's why it's not able to fit in my memory. So what we are doing is we are just converting into 4-bit equals true, and this library is doing something so that even this big model is set to only 5 bits. 875 MBs into 32 KBS. Okay, I don't know how that 875 came, but yeah, I'm not good with that numbers yet. I have to learn that as well, how this memory management works. So yeah, so that's how it is. So now currently the idea is, if the model is, let's say if I don't use this one, it will take I think 16 GB of RAM, and just because I'm having this particular case, it is taking only 5 GB of RAM, and this is done because we are having this library called bits and bytes. What is it? Where is it? Bits and bytes, right? Exactly. Yeah, in particular this one they are doing some 8-bit optimizer, and it is going to take, I don't know, matrix multiplication, some function it is taking. Yeah. So yeah, this is what I am planning to read more about today, how this memory management is done. And another thing is QLoRa. So again, I'm also new to this, what do you say, quantization function, efficient fine tuning, all those stuff. Yeah. Okay, writing slow. Nice. Let's see. I still have to read this stuff. And also, yeah. Bits and bytes. This PEFT is the one we are using to, remember I told we have to fine tune the model, and this is to fine tune a language model I'm trying to do. And I used PEFT, I did the fine tuning and it worked perfectly fine. But the problem is I don't know how the hell the PEFT works. What are they doing inside of it? That I have to figure it out. So yeah, all these supporting materials I have to read. How the hell LoRa works, speed tuning, prompt tuning. So yeah. Anyway, so and yeah, this is where I'm right now. So Python transformer, this is the one, like a god savior for every machine learning engineer, hugging face. A community. Yeah. Okay. What's the time now? 2 o'clock. Huh? Yeah. Okay. Let me go back to this Falcon and see how the hell Falcon is running. Now when I give this one, it is working, but why it's not working here? Transformer dot model equals model tokenize data type. Not tokenize pipeline, right? That is transformer pipeline. GPTQ. Quantization. It's a full form. Bits and bits and bytes. It's 2:11. 2 மணி ஆச்சு. Okay, I think I should end the stream. I'm feeling sleepy and the brain is not working. Thanks for the 2 people who are watching. And yeah. Okay guys, then let me end the stream. Maybe I'll do another stream tomorrow if I don't know if I have some energy and interest, and let's see. Okay, thank you. Stopping the stream.